Hello everyone. For this tutorial video, I like to talk about more sophisticated types of line integrals, in particular, line integrals of multivariable functions, with respect to change in x or change in y, or change of the inputs, rather than change in arc length as the last video. The formula for a line integral with respect to change in x is function of x of t, y of t, times the derivative of x of t with respect to change in the parameter t. The line integral with respect to y is about the same thing, except we use y for the derivative and change of y that we are integrating with respect to. If we remember how line integrals can be broken up into smaller line integrals, it should follow that the line integral of p times change in x plus q times change in y can be split up into two separate integrals, one with respect to x and one with respect to y, as shown. For example, if we want to integrate this line integral, and noticing that we are integrating with respect to change in x, we would do this first by expressing the line we are integrating on in terms of a parameter t, which would be t, 2 plus 2 times t, where t is in between 0 and 1. We next split up the integral into two separate integrals, one with respect to change in x and one with respect to change in y, and then compute the integrals using the techniques we know already. And we conclude that the exact line integral is 7/6. Now that we have figured out more sophisticated line integrals of multivariable functions, we can talk about line integrals of vector fields next, which can be used to estimate the total change in a vector field. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.